Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video we'll be talking about naive Gauss elimination method. And this method has to do with forward elimination of unknown and backward substitution. Okay, so if you follow this playlist so far, you will observe that we are just trying to look for ways to solve, or different techniques to solve numerical techniques, not just techniques, okay, numerical techniques to solve equations, okay, partial differential equations, ordinary differential equations, systems. Okay, so now we have a system here and we want to solve it using Gauss elimination method. So now there are two basic steps to take. One of them is the forward elimination of unknown and then back subdivision of unknown. So what you do is this. Now we have the three equations. Solution. So you take the three equations. The first thing to do is to eliminate x1 term in equation 2. So looking at the equation now, you go to this equation, remove x1 term from this, remove x2 term from this. Next thing, remove x2 term from this. Let's just go step by step so you see what we are talking about. So the first thing is to what? Eliminate x term in equation 2. How do you do that? What is the coefficient of x term in equation 2? 0.1. Now, what to do is this. That 0.1, the coefficient, you bring it here, divided by the coefficient of equation 1. Okay? Now, what you have inside here is what? Is what you have in equation 1. So this thing is the coefficient of equation 1, x1 term. So, in order to eliminate x2 term in equation 2, take the coefficient of in order to eliminate x1 term in equation 2, take the coefficient of x1 term divided by the coefficient of x1 term in equation 1, then multiply by equation 1. When you do that, you will have this expression. Okay? Then that answer, sorry. When you do that, you have this expression under. Okay? Then the answer, you subtract it from equation 2. Okay? So let's make this bigger and clear. So this is from equation 2. This is from equation 2. Okay? This is from equation 1. This is from equation 1. And this from equation 1. Okay? Then this you have here is the result of this. Okay, so many colors. But I hope you understand what I mean. This is from equation 1, from equation 1, from equation 2, from equation 2. Then this under is the result of this expression. And this expression is simply the coefficient of x1 in equation 2 divided by the coefficient of x1 in equation 1 multiplied by equation 1 subtracted from equation 2. Okay? And we are doing this in order to eliminate the x1 term in equation 2. Okay? Now, so when you do this subtraction, you will get this number. Alright? Now, with this, x1 term has successfully been removed from equation 2. This will be the new equation 2. Now, we are also going to eliminate x1 term in equation 3. So we repeat the process, saying that the coefficient of equation 3 is 0.3. Coefficient of equation 3 divided by coefficient of x1 in equation 3 divided by the coefficient of x1 in equation 1 multiplied by equation 1 subtracted from where? Equation 3. So this thing will result in what? This. And this answer is subtracted from what? Equation 3. You will have this expression. This will be your new equation 3. So we write them out now. this equation 1 remains. Equation 4 is exactly the same as equation 1, but equation 5 is our new equation 2, which we got from here. Look at it. Then equation 6 is our new equation 3. Are we seeing it now? So since we still have x2 term here, x2 term here, we are going to eliminate x2 term in equation 3. Are we seeing that this is forward elimination of unknowns? So we are going to eliminate x2 term from equation 3 by repeating the same process. What is the coefficient of x2 in equation 3? You bring it here. Coefficient of x2 in equation 2, you bring it here. Multiply by equation 2. You will get this result. This result, you now subtract it from equation 2. That will give you this result. This will be your new equation 3. Okay, so equation 7 is exactly the same as equation 1 and 4. Equation 8 is exactly the same as equation 5. Equation 9 is this you have here. So now we can see that equation 9 we have only one unknown, which is x3. So now, making x3 subject formula, you have this as x3. Now you substitute back. This is the backward substitution now. Equation 8 has two unknown, but thank God we now have the unknown x3. So you now do what? You substitute into equation 8. So this equation 8. Here is where we have x3. We substitute that value there. So we just simplify and we get x2 as this. Now we have x2 and we have x3. So substitute x2 and x3 into equation 7. So where we have x2, you put that x2 value. Where you have x3, you put x3 value. And that will now give you x1 as this. That is it for the naive Gauss elimination method. Okay. In the next video, we'll talk about Gauss-Jordan elimination method, and they give the same answer. Okay. So thanks for watching, and I'll see you in the next video.